for part one of the project assignment. So the first question is to just draw the mass damper system. This is the mass, this is the spring, this is the damper, and this is the force F of T acting on it. They say external harmonic force is acting on it. So you draw your F of T there. Also take note of the values we are given. We're going to use that later. So for question two, he wants us to draw a phasor plane. What does a phasor plane look like? If you come to Praise's notes here, this is what a phasor plane should look like. And this is the equation used to get the phasor plane. I'll show you how to get the equation for this question we're going through. So coming back to the question, remember that this is the diagram for the system. This is our equation of motion. Please recognize that this is actually cos WT. I mistakenly omitted it. Technically, yeah. So yes. Now we're going to make these substitutions. This is position, this is velocity, and this is acceleration. We're going to put x into the x here. Let's put x dot into here. Let's put x dot dot into here. So you should get this formula. This formula here. This equation here. Please don't forget to put the cos WT. I omitted that by mistake. So now, how to draw the phasor plane? Draw your x. Sorry. Draw your x, y. Sorry, y and x axis. And there's a little quadrant that we were taught in 200 level. This and this cos, this is sine, and you usually start from here and start going around the quadrant. So you're going to start from cos. That's why we're going to start from this one, because this one has positive cos in its starting. So first we're going to model this first. So just draw a line. This line is coming out by an angle of WT minus phi, and it has a magnitude of cx naught. Next, we're going to model this one because it has negative sign. If you're moving like this and you get to, you can see negative sign. So we're going to model this one next, and it differs by 90 degrees. So we're going to draw a line 90 degrees for this. It has a magnitude of k x naught w. So just going to draw k x naught w. And then for the last one, this one is negative cos. If you move from negative sign to here, so it is negative cos. You're going to have negative cos. So we're going to model this next, and it's 90 degrees because this is 90 degrees. It's 90 degrees from here. And the magnitude is mx naught w squared. Now when you join the line from here to here, the length of this line is going to be f naught. And f naught is coming out at an angle of WT. So f naught cos WT. So from here to here will be WT. If from here to here is WT and from here to here is WT minus phi, from here to here will be what? WT minus WT minus phi, which is going to be WT minus WT plus phi. It's going to equal just phi. So from here to here is just phi. Now this is just how your phasor plane should look like. That's I just told you how the phasor plane should look like. Now the question is now saying estimate the resultant force F naught, that is this line here, when the angular frequency is 3 rads, 4.5 rads, and 3.6 rads. So we have our equation here, right? Okay, so when W is equal to 3 rads, we're going to substitute into the equation. We know what M is. M is 2 kg, just given the equation. X naught, that is initial position, it's X, which is 10 meters, and W in this case is 3. You put in your parameters there. The same thing, you fill in the numbers for the rest of them. F naught doesn't have anything, so just leave F naught as it is. One is 3.68 rad, 3.162 rad, sorry, that's this here. You put in your numbers and you solve. the same for here minus 4.5, put your numbers and solve. So now we have our three equations, but this is still cos WT, cos WT. Putting our three equations, and now we have to draw the phasor plane for each of them. That's for 1, 2, and 3. We have to draw a phasor plane for each of them so that we can be able to find f naught, because that's what the question is asking. It wants us to find estimated resultant force f naught. So for W cos I want to draw the phasor plane for that. This was my equation. I want you guys to notice that this 180 was gotten from this. This was gotten from kx naught, and this was gotten from cx naught. Just W. Yes, so take note of this. So remember I told you when you're drawing the first line here, this line is going to be cx naught. You got it here. Cx naught. And cx naught in this case is what? Cx naught in this case is 200. So right here with 200. Then from here to here will be your kx, which will be 150. So here says 150, here is 180. Then I told that whatever joins from here to here is will be your f naught. So you just take a ruler and measure from here to here, and that will be your answer for f naught. You do the same for each of the equation. Cx, you first draw 200, followed by this 158.1, this 106.96, and then you join the line here, and you measure it. What it is? Wf naught. Do the same for the third question as well. 200, 225, 105, and then join your line here. Measure the line from here to here, and you get what your f naught is. Let's say f naught equals 4.38. Now the question also says, so we have found our f naught. Now the question says we should find our phase angle phi. This can be gotten from the same diagram. So from here, I told you that from here to here represents phi. If you look at the diagram, from here to here is 82.41, so my phi is 82.41. From here to here is 0.99, so phi is there. And from here to here is 132.34. Yes, so that is just it. We're cutting our phi and f naught. Now he said to comment whether you see any notable changes in the system and document all the observations and changes. Personally, one thing I observed is that as W angular frequency was increasing, phi was also increasing. So you see it as 3 relatives is 2.4, it's 3.16, phi increases. Here again, phi increases. Another thing to notice that was written in Chidben's group work was that, okay, see for W equals to 3 right, this is 180, this is 150, this is 200. You can see that 200 is the greatest force here. So therefore, I know this is the spring force. This same is for spring. The spring force is the highest force. It dominates the system here. Meanwhile, you see for this one, this is approximately 200. Mx w square and cx naught, that is inertial force and spring force, are like almost equal to each other at this frequency, at this angular frequency. And this angular frequency 4.5, you can definitely see that mx dot w square takes the cake, and this is inertial force. It takes dominance in this system. So those are the observations and changes you can actually write for him. Then next is just to plot the first angle. So first angle against, you can see an f naught against w, that's angular frequency. This is the plot. Yes, so you can, this is the plot, sorry, this is the plot. You can definitely see that, so this is the plot. You can definitely see that phi is directly proportional to the angular frequency w, and the force is directly proportional to the angular frequency. So you can just say that you notice the observation. So this question number 3, he wants us to calculate the amplitude and the phase angle. Is it this amplitude is asking us to calculate? You may think it's x naught. That's wrong. It's asking us to calculate the amplitude of the force F naught. So, and the phase angle, that's phi. So F naught and phi. I want you to know that this x is equal to 10. This is equal to x naught. X naught is technically initial position, so x naught is 10. Now this formula for amplitude is gotten from a derivation in his work. In his excitation notes, you can see when you go down the line, bring out some triangles and everything. So you're going to get this formula here. And also for phi, you're also going to get this formula here as well. So you can go and look at the work, look at his work in his notebook to see how he got it. But basically we're going to use formula for the amplitude. So this is the formula. Now we need to, what we're trying to find is f naught, not x naught. So we're going to make f naught subject of formula here. This is what we're going to get. Now all you just need to put is put in values for w equals to 3 rads, because you still need to find it as when w equals to 3 rads, 3.162 bar and 4.5 rads per second. So when w is equals to 3 rads, you get to have f naught is equals to, x naught is 10, the square root, what's k? K is, this will now be root k is 5 times, in this case w is 3, so 3 square plus what's c is 20, so 20 minus m2 times w is 3 square is about 2. If we solve this out, you should get that f naught is equals to 151.33. So you repeat the same for when w is 3.162 and when w is 4.5. You're going to get f as this and f as this. Now for the case of phi, again from his notes, see when he solved, he got this. So you can look at his notes. And when you make phi subject form, it will be tan inverse of this. This omega can be also written as w, so don't mind it.